So, simplifying rational functions. What is a rational expression? A rational expression is a ratio of polynomials. That word, ratio, what is it? It has to do with division, yes. They are related for sure. That first part of rational is ratio. You learn about them like a lot earlier. You don't always like express them the same way. Sometimes you see them show up in other places like cooking or science.
I like a ratio of like 4 to 2.
Right. So like you might have like, I'm going to do like 2 to, let's do 2 to 3 because 2 to 4 will reduce. So like this might be, if you're cooking, it might be that you need like a 2 to 3 ratio, like with rice. If you were cooking 2 cups of rice, you need 3 cups of water. But if you want 4 cups of rice, you need 6 cups of water. That sort of thing. Or you might also see it like if you're mixing up like chemicals, you might need like a 2 to 3 ratio. If you might need 2 cups of this chemical to 3 gallons of water if you're like mixing up weed killer for the yard or something like that. So ratios show up in a lot of different places. There are 3 ways that we can express them. You can just say like this much to this much. You can use the colon like this, or everybody's favorite and what we will be using for this class, they can be a fraction, 2/3. Yeah. So the difference in what we are talking about here, like ratios of 2 to 3, and a rational function, is that we are going to have variables involved, right? So this would be an example. You have a variable both on top and bottom here. It has to have a variable in the bottom to be rational. I guess it can just be a number in the top for those. Okay, so that is what we will be looking at today. Simplest form is going to be what we're going to be focusing on today. And this you already know a lot about whenever you're talking about just regular fractions. For example, my cousin, this has been several years ago, but he was saving up money for like wheels and tires for his truck. And he told my dad that he was 2/8 of the way there saving up the money. And my dad made fun of him a lot for that because a normal person would not say 2/8. What would a normal person say? They might say 1/4, they might say 1/4, they might say 25% of the way there, but 2/8 is a weird way to say that because normally when we talk about fractions, we want them simplified down to their like most simple form, right? So that is definitely true whenever we're talking about just regular fractions. It is also going to be true when we're talking about rational functions. So the numerator and the denominator cannot have any common divisors. There can't be anything you could divide both top and bottom by. And you simplify by dividing out common factors. And you're seeing that word factor show up a couple times already. That should let you know that we are still going to have to be able to factor to do these problems. So if you thought that it was done in Unit 3, it unfortunately is not. We do still have to be able to factor for that. So this next slide, I will say these are not my notes. I didn't pick out this meme right here, but I did leave it on there on purpose because I got these notes from Miss Martin, and I'm not even sure if Miss Martin came up with it. I think maybe Miss Martin got this from one of her friends at North Surrey that from whenever she taught there. So I did not come up with this, but it is very important for you to remember that you cannot, whenever we are simplifying rational expressions, there's a certain way we have to do things to cancel. Okay? So, whenever we simplify a rational expression, we are going to factor the numerator, if it is possible. Sometimes it's not. We will factor the denominator, if it is possible. Sometimes it is not. And then we reduce using the factors, not the terms themselves. Okay? The difference in a factor and a term is factors are separated by multiplication. Terms are separated by addition or subtraction. Okay? So, if you look at our example right here, where we've got x squared plus 2x plus 1 over x squared plus 3. It is true if I have x squared divided by x squared. Something divided by itself is 1, right? These two cancel out and I'm just left with 1. Okay? That is true if I just have x squared and x squared. It is not true if I have other stuff added to it. So kids want to do this every time whenever we do these problems. It is the most common mistake made. Some of my calculus kids still occasionally do this wrong whenever we have a problem that requires this. You cannot cancel if what is separating the other terms is addition or subtraction, right? So like this x squared and this x squared are separated from the remaining stuff by a plus sign. So you cannot cancel that. It does not work. It would be, for example, if I had, let me switch colors. Like, if I had 2 plus 3 over 4 plus 3. Okay? So if I have that fraction, what does that equal? 5 on the top, 7 on the bottom. It's 5/7, right? This is correct. But if I cancel like they're canceling over here, I would say, oh, there's a 3 on top, 3 on bottom. I'm going to mark those out. What would I get? 2/4, which would be 1/2. Is that right? No, that would be wrong. So we cannot cancel by just marking things out on top and bottom that are the same if they're separated out by a plus or minus sign. It's very, very, very common mistake. And as this meme tells you here, every time you do this, a kitten dies. So don't do it because kittens are adorable and we want them. It kills the kitten every time. I sometimes say it's a math fairy that dies. So that's not good either. The math fairies like come sit on your shoulder while you're taking the test and give you the answers. So you don't want to kill them. We need as many of them around as we can have. So a kitten or a math fairy dies if you try to cancel this way. So don't do it. We already had Victor already killed a kitten this morning. This very morning in first period, Victor killed a kitten. So we don't want any more to die today. So in a second, yeah. Correct. Okay, so let's look at doing some problems, and then we're just going to work on a few until it's time to go. We're out at 11 today because we're a little bit short schedule for the pep rally. So whenever we're doing these problems, we want to factor the numerator and denominator. The numerator is already factored here. The denominator is almost factored. But is there anything in the denominator that we could factor more? That x squared minus 1 can factor again. Right? So the top, we're going to leave it alone. X plus 1, x minus 5. And in the bottom, we're going to have x minus 5, stays the same. But then x squared minus 1, I can factor like this. And so I'll have an x and an x, what numbers do I need to use? Positive 1, negative 1. Okay? Because if you're an X method person, you're trying to get a negative 1 when you multiply, a 0 when you add, right? And the only way that you can do that is with a positive 1 and a negative 1. Right? Or it's just guessing check there. So before we start marking things out, okay, before we start marking things out, because we're going to be able to cancel some stuff here in a second, we have to look at, these problems have what we call excluded values. So excluded values. What does it mean to exclude someone or something? Remove them, leave them out, not include them, right? So there are some numbers that cannot be put into this equation, okay? There's some numbers that cannot be put in because they're going to give you a 0 in the denominator. And what is anything divided by 0? No, not 0. What if I have like 6 divided by 0? Close. There's a word that it... Undefined. Okay? So, 6 divided by 0 or any number divided by 0 is undefined. That means if these three things in the bottom equal 0, then our whole function is undefined, right? So, what number would make this x minus 5 undefined? What would make it 0? Positive 5. So we're going to say x cannot equal positive 5. Okay? So we put an x, and you don't have to like write it out in words because mathematicians try to use as few words as possible. We can just put equal sign, slash it out, and that means does not equal, right? So x cannot equal 5. What about for this one, x plus 1? That's a negative 1. X cannot equal negative 1. And what about the last one? Positive 1. X cannot equal positive 1. This is part of your answer because when we start marking things out, it's not going to be quite so obvious what values you can't plug in. So you want to include this with every one of your answers. Pretty much everything's going to have it for these type of problems. Okay? So now that we have our excluded values, we can start canceling. What could I mark out? Okay? Just the ones? The whole factor can go. X plus 1, x plus 1. It is okay to do that. As long as I'm canceling the whole factor. Because this stuff right here is multiplied by x minus 5. Not added or subtracted to it, right? And this stuff right here is all multiplied. So I can mark that out. Okay? What else will cancel? The x minus 5 and the x minus 5. The whole factor, right? Alright, so that is going to leave me just with x minus 1, and it's on the denominator. Can I leave it like that? Something's got to go in the top. What goes in the top? What is it, Lewis? It's 1. Okay? Because could I put like a 1 times the stuff in the top? I could, and that's going to be left. It's not going to be 0 because 0 divided by anything is 0. It's not going to be an x. Because there wasn't an extra x up there. Okay, so this is my answer, but with it, I'm keeping in mind that I cannot plug in 5, negative 1, or positive 1 to this. You have to do your excluded values before you start marking things out, because if we just looked at our answer, we would only have positive 1 as an excluded value, right? So you've got to do those excluded values before you start canceling.
So does that mean there's 3
The answer is 1 over x minus 1. There are 3 excluded values. So these are numbers you cannot plug into that. This right now is just asking us to like simplify. We will get to a point where we're like solving equations, which will be a little bit different. But right now we're just working on like factoring and canceling to simplify, which will be part of solving later on. Okay? All right, questions? All right, so for part B, on that first line, stuff is not factored. So we're going to need to factor it. Is there a greatest common factor for the top or the bottom? There is not. Okay, so we're going to go straight to our sets of parentheses. Okay. For the top and the bottom, we're both going to have X and X here, X and X here. Christian, you with me? Okay. Okay. Lanaya is telling me to do positive 4, negative 3. Does that look right? Okay. If you're X method person, you're multiplying to get negative 12. You're adding or subtracting. To get positive 1, and that has to be a positive 4, negative 3. Yep. For the bottom one, it's almost the same thing, but we'll have a positive 4 and a positive 3. Yeah, because if we're doing X method there, you're multiplying to get 12. You're adding or subtracting to get 7. That'd be positive 4, positive 3. Okay, now before we start marking things out, because there's some stuff we're going to be able to mark out, we need to do our excluded values. You're close. It's not all of those. Okay, excluded values only come from the denominator. So that positive 3 is not going to be 1 because it's okay to have 0 in the top. You can do 0 divided by 7 because, like division, I like to think about bringing cookies to class for division. If I bring in 100 cookies and have to divide them amongst my 23 students, we could divide to see how many cookies you each get, right? If I bring in 0 cookies, how many cookies do you each get? 0 cookies. I demonstrated that today by bringing 0 cookies to you. But I can't, if I have cookies, if I have a number like 6 and I try to divide it by 0, I can't do that because if I have cookies, they have to be at least in one group, right? Like somebody's got to have the cookies because they exist. So it's only the bottom that it cannot equal. So that will be X cannot equal negative 4. Notice we're using the opposite sign right there because negative 4 plus 4 would give us 0. And then X cannot equal negative 3 because we're using the opposite sign. Yes. Yeah. It can be a little more complicated if it's like the more difficult factoring where you might have like 2x plus 1. We're not going to see a lot of that today. It's mostly going to be these simpler ones. All right, now what can we cancel out? What factors can cancel? The x plus 4s, right? The whole thing right there. And so when those cancel, can x minus 3 and x plus 3 cancel? No, they're different signs. They're not the same. You're looking for the number that would give you 0 in the bottom. So you're kind of thinking like, so it needs to be the opposite sign because if I used a positive 4, 4 plus 4 would give me 8. Right? That wouldn't give me a 0 in the bottom. So use the opposite sign because that's the value that would give you 0 there. Okay, and this is our answer, but we also do have the excluded values. You cannot plug in negative 4 or negative 3 into this. Everybody okay there? All right. Let's look at the next one. Okay. Do we have any greatest common factors for those? Yeah. Can I divide x squared by 3? I cannot. If there was a number in front of the x squared, it would work, but you got to have all 3 terms. So there are no greatest common factors. The top and the bottom both will factor here. Here I'll have x and x. What numbers could I use? X plus 3 and x plus 3. I think that'll work because I'm trying to multiply to get 9, add or subtract to get 6, That'll be positive 3, positive 3. Okay? X plus 3, X minus 3 on the bottom, because I am trying to multiply to get negative 9. What am I trying to add or subtract to get? 0, because that middle part right there is missing. So that has to be positive 3, negative 3. Before I start marking things out, I want to do those excluded values. And Demetrius is correct. It is going to be X cannot equal negative 3. X cannot equal positive 3. Okay. What's going to cancel? The X plus 3 and the X plus 3. I cannot cancel this X plus 3 because I've only got one X plus 3 on the bottom. I can't cancel that twice, right? So it's got to stay. And I'll have X plus 3 over X minus 3. So that's my answer with the excluded values of negative 3 and 3. Okay, this last one requires you to remember something else. How do I factor that top? What? You can do it that way, but it's not going to work out the best.
When you divide both sides by 4x.
Yeah, 4x. Greatest common factor there. So divide by 4x. So if I divide both of these by 4x, because this numerator does have a greatest common factor, then I will just get an x here and a plus 2 here. Will that break up into two sets of parentheses any further?
No.
It will not. Right, so I'm done factoring that numerator. Does the denominator have a greatest common factor?
Oh, wait, no.
No, not because of that x squared right there. So we're going to have two sets of parentheses here. We've got x and x. Okay, positive 4, positive 2. Okay, if I multiply, I'm multiplying to get 8, adding to get 6, positive 4, positive 2, that'll work. Whenever Christian gets back, you can go. Alright, so I was about to cancel, but what do I need to do first? Excluded values. So I'm running out of room right here. Let's squeeze this. Excluded, I'm not going to write values. What are my excluded values? X cannot equal negative 4. X cannot equal negative 2. Alright, and what cancels here? X plus 2's right there. Alright, so that'll give me 4x over x plus 4. They're the same on top and bottom. Okay, now, could I mark out the 4's here? Why not? Okay. On the bottom here, that 4 is added to my x, right? So I can't mark those out because that would kill a kitten if I tried to do that. So I'm done right here. Okay. No. Okay, we're gonna, I'm gonna change that meeting to a math fairy because the comments I'm getting are a little troubling. Okay, alright. So for number 1, there's no factoring to do on this one, okay? Because you don't have like any plus or minus signs. So the coefficients, the big numbers right here, you just reduce them like you would normal fractions, okay? So what number could I divide both of those by? I could divide both of them by 20. So on top, it's going to give, the negative just stays out front. On top, it's going to give me a 3. On the bottom, I'm going to have a 1. You don't really have to write the 1. You can if you want. This is as far as it would let me go. I'm dividing by 20.
No, I'm saying the numbers that she said. I couldn't.
Yeah, I'm dividing them by 20
Okay.
is what I wrote right there. Yeah, I'm dividing by 20. This was as far as it would let me go for some reason on this one. Okay, and then we can think of this like this. On top, we've got 1K. On bottom, we have 2Ks. I could split them apart right there, right? What happens when I have a K on top and on bottom? They cancel out right there. So for this problem, I would get negative, well, let's leave the negative out front. Negative 3 over K. You can put 1K if you want, but that 1's not necessary. I forgot to do excluded values. What number would make the bottom of that 0? No, not negative 20. Not positive 20.
1, 0.
0. Okay, because for these problems, there's not like a plus or minus. So what you're kind of thinking of is like you got 20K squared. What would make that 0? So you're like dividing by 20. And so K squared is still going to be 0. You would square root, but that's still going to be 0. You'll notice if like you don't have any pluses or minuses, you just have a variable, like that is pretty much 0 all the time, right? So like if I do number 2, what's my excluded value for number 2? It's also going to be that x cannot equal 0. So if I want to reduce that one, what number could I divide the top and the bottom by? 4. I could divide by 4. So if I divide by 4 on the top, I will get 3. If I divide by 4 on the bottom, I will get 4. It's just reducing like you would reduce a normal fraction, right? And then on top, I've got 2 x's. On the bottom, I've got 4 x's. Correct. So I'll cancel these out, and I would get 3 over 4x squared. Right there. With the excluded value of 0. So on these first ones, so all the way up, or so 3 and 4 are the same as that. There also might be one, there might be a couple towards the end where this happens as well. The ones in the middle are pretty, 5 is hard.
Wait, so the X, what's the excluded value?
0. If you don't have like any plus or minuses, if it's just a variable multiplied by something, even if it's like squared or something, it's pretty much always 0. Because if you put a 0 there, like 0 times anything will do 0. So like 3 and 4, the excluded value would also be 0 for that. Okay. Let's skip down and do 5. 5 is a weird question. And then I'm going to let you guys loose to do the rest of these. Okay, can we factor the top of that for 5? I can't do anything to the top. What about the bottom? It's not going to factor into 2 sets of parentheses. Does it have a greatest common factor?
Yeah.
What is it?
7 times 6 is 42.
Yeah, so 7, if I'm dividing both of those by 7, I will get v minus 6. But does anything cancel? They can't like they are right now. They cannot. But they're so close to being able to cancel, right? Does that work? Can I just switch subtraction? Like is 2 minus 3 the same as 3 minus 2? No. What did you say? Okay. So, what about if there's a couple ways I can deal with it. And it involves a negative. So what about if I factor out a negative 1 out of that numerator, right? So if I were to divide that numerator by negative 1, so I'd have negative 1, and I'm dividing this by negative 1, and I'm dividing this by negative 1. Dividing by -1 just switches my signs, right? So that would make this -6 plus v. And on the bottom, I'd have 7v minus 6. Okay? Can I write it this way? V minus 6, like that. Is that okay? If I have -6 plus v, can I write that as v minus 6? That's okay, right? Because I kept my signs like they were. And then 7 over v minus 6. And now, does anything cancel?
Yeah.
Now my v minus 6 is canceled, and I just get -1 over 7. What would the excluded value be? I forgot to put that. X cannot equal a positive 6. So that one's a little tricky, but if you see that, like they could almost cancel, but they just need to switch in their subtraction, that is what you'll do for those. Okay, do as much as you can. We've still got 20 minutes, so I think you should be able to get a lot of it done. How much of it is going to be homework is going to depend on how well you are working. So if you're working hard, you might not have any. So. Oh, okay. Sorry. There you go.